All right, everybody. So I am recording, right? Yeah. Okay. Um, okay. In this video, we're definitely going to get into word problems. The last one we were talking about, kind of the prep work for it, learning to translate a little bit from English to math. All right. So three consecutive integers have a sum of 78. All right. So remember, in your math class or anywhere in life, if you don't remember how to do it the way the teacher or the rule book says to do it, but you can think of a different way, that's fine. Okay. For example, okay, so three consecutive integers. Integers are numbers like one and negative one, two and negative two, three and negative three. So three consecutive integers would be like two, three, four, or um, 16, 17, 18. Okay. 21, 22, 20, 24. That would not work because these two are not consecutive integers. Okay. All righty. And so, like I said, if you can't think of the algebra way or the quote unquote correct way of doing it, try something different. That's life. Okay. You might say, all right, well, I don't know, maybe 16, 17, 18. Does that add up to 78? Let's see, it's 10, 20, 30, 45. That's 51. Adds up to 51. Nope, not big enough. Okay, so maybe try, I don't know, 20, yeah, I don't know, 22, 23. I don't know what the answer is, 24. I rarely will look up the answers in advance. So yeah, it's 69. Ooh, that's getting close. Maybe, what if we went like 24, 25, 26? That'll be 67, 75. Okay, so 25, 26, 27, that adds up to 78. Boom, we just found the answer. That's the answer. Now, obviously, that's not the way you're expected to do it, but I want you to learn how to do it, the algebra way, but it's okay to use other methods. Okay, algebra is not the beginning and end of all knowledge. Okay, not even close, although it's a very useful tool. Very. So here is the way that you're expected to do it. Is to say, all right, well, I'll say x. Here let me just type this, and that'll be easier to see because my hand. We'll say x equals the first consecutive integer. Okay, well, if x is the first one, how much bigger is the next one going to be? Well, it's going to be bigger by 1. So x plus 1 will be the second consecutive integer. And then the third consecutive integer is going to be 1 bigger than that. So x plus 2. That'll be the third consecutive integer. Okay. I also want to type because then it doesn't take up as much room on my page. Okay. So they tell us that the sum of these consecutive integers, I'm going to start switching up colors here to make it easier to see. The sum of these three consecutive integers is, that's the equals, 78. And then we just solve the equation. So we'd say, oh, okay, well, I got x plus x plus x. That's 3x. 1 plus 2 is 3. And then I'll subtract 3 from both sides because I want to be cool. Oh my gosh, I can hear my family playing Settlers of Catan. I'm up here doing a video. I mean, it's very cool being with you, but I would like to be down there. And then I'll divide by 3, and x is 25. Now, what does x stand for? Well, x by itself stands for, that's the first consecutive integer. So if you want the second, add 1 to it and get 26. And if you want the third consecutive integer, add 2 to x, to 25, and get 27. And we get those guys right there. Okay. So please don't be one of those people, and there are many of them out there in math classes. They're like, I don't remember how to do it the algebra way. Oh, well, I guess I'm going to get it wrong. It's like, really? You can reason it out pretty easily. Okay. It's not that bad. if you just stop and think about it. All right, let's go on to the next one. All righty, everybody. Christine, I know a lady named Christine. Let's choose a number between 49 and 95. That is a multiple of 3, 5, and 10. Write all the numbers that she could choose. Well, I mean, I guess we could just say, start with 50 and go up to 94 and just say, does this work? Does that work? I mean, that would work. Let's see. Well, but maybe we can make this easier. First of all, well, kind of like we did with the listing method, it might be easier just to, take the biggest number. In fact, let's do the listing method. Okay. I mean, yeah, the way I do it at least, I'll take the biggest number and I'll say, all right. So it's 10, 20, 30. What comes next? Oh yeah, 40, 50, 60, 70, 80, 90, 100, and that's probably far enough. Okay, but we want numbers between 49 and 95, so not those. Okay, they're all out. Great. Now, and because 3, 5, and 10 all have to be, all have to divide into it to the numbers we're looking for, if we start with our biggest number and find its multiples in the interval, then we should be able to get to what we're looking for a little faster. All right. So what about, okay, does 5, is there anything in our interval that 5 does not divide into? No, 5 divides into all that, so it's cool. How about 3? Does 3 divide into 50? Nope. 60? Yes. 70? Nope. 80? Nope. 90? Yes. So we're left with 60 and 90, and that's it. And that is how I would do it. That'd be the easiest way I know, except for doing it on the calculator. All right, so next one. A bookstore had 48 copies of a magazine. That's cool. Yesterday it sold 1/3 of them, and today it sold 7/8 of whatever remained. So how many copies does the bookstore have left? All right, so the bookstore had 48. They got rid of or subtracted away 1/3 of 48. Okay. And okay, so let's just figure that out first. All right, 1/3 times 48 is 16, and 48 minus 16 is 32. Okay, so by the end of yesterday, they had 32 magazines left over. They sold 1/3 of them. They still have 2/3, 32 of them. All right, now today it sold 7/8 of that. So now we want to do, so we've got 7/8 this morning, and we get rid of 7. I'm sorry, we have 32 this morning, and we get rid of 7/8 of means multiply, of what we currently have. And we currently have 32. Well, I suppose we could cancel an 8. So 8 divides in once and 4 times. Okay, let's see. Is this the color I was using? Yeah, I think so. Okay, so we've got 7 times 4 is 28 over 1. And we're left with just 4 magazines. And I mean, I figured we wouldn't be left with much because it says if you sell 7/8, I mean, 8/8 would be everything. 8/8 means you sold everything. So, and 7/8, well, that's almost everything. So I wasn't expecting to have much left over. Which reminds me, when you do word problems, always think, okay, does my answer seem reasonable? Or even at the beginning, you could say, all right, what should my answer be? Okay, so if I were to have done that on this one, I would have said, all right, 48 magazines, I get rid of 1/3 of them. All right, but I still got over half. But then I get rid of almost all of those. So I don't know, 10 at the most is what I should end up with, probably a lot less. And 4 certainly falls into that category. All right, so another word problem. Brian's gas tank is 1/5 full. Okay, so I mean, let's face it, your gas tank looks like this. Okay, here's the quarter mark. So Brian's gas tank is a little below a quarter. Okay, it's 1/5 full. 1/5's a little less than a quarter. Okay, so that's about where he is. After he buys 9 gallons of gas, so it's going to get bigger. He's going to have more. It is 7/10 of the way full. Well, this is our 3/4 mark right here. And so, you know, or 75%, 0.75. Well, 7/10, that's 0.7. So that's going to be just a little bit below the 3/4 mark. Okay. So how many, and if you're colorblind, you can't tell the difference between these colors too much, probably, if you're like me. But that's okay. It'll be okay. Okay, how many gallons can Brian's tank hold? Oh, okay. So what's a full tank? Yeah, I don't know. I suppose it could be all kinds of things. So 9 gallons of gas gets him from the 1/5 mark up to the 7/10 mark. Okay, that's about half a tank. It's not quite. It's a little off from half, or yeah, that's a little different than a half a tank. Because just as a half a tank goes from there to there, a half a tank then from here to here is pretty close. I'm just moving both markers back a little. Think of the chains that they used to use in football games to see if they made it to the first down. Anyway, so that's about half a tank, 9 gallons. So I would expect pretty close. So if 9 gallons was about half a tank, then about 18 gallons. That's going to be about a full tank. Okay, so there's my estimate. And if my answer is really far off from that, then I'm not going to be very comfortable with that answer. Now, before we solve this one, I want to point out probably a fairly common way to do this problem incorrectly, to do it wrong. Here it would be say, hey, we've got, okay, so 1/5 of a tank plus 9 gallons is 7/10 of a tank. Okay, cool. The only problem is if you go 1/5 plus 9, that's 9 1/5, which is not equal to 7/10. 7/10 is less than 1. So how come this doesn't work? Well, because this is the percentage. These guys are percentages of the tank. Okay. And this is not. This isn't 9%, it's 9 gallons. So these guys are not like terms. Okay, and so I can't set it up that way. That doesn't really make sense. Okay, so I just wanted to point that out before we actually do it. Okay, now to handle that issue, I'm going to say this. All right, x equals number of gallons tank can hold. So in other words, x is the number of, it's just how many gallons that we're looking for. Usually, whatever they ask you to find, you just call that the variable. Okay. So when it's 1/5 full, the number of gallons that we're talking about at the 1/5 full mark would be 1/5 x. Okay, or in other words, 1/5 of multiplication, the number of gallons that can be that the tank can hold. Okay, so this represents how many gallons of gas the tank contains when it is 1/5 full. Now, by the same token, when it is 7/10 of the way full, it's currently holding 7/10 of the tank. All right, of the maximum gallons it can hold. Now, if we take what we started with, that because again, these quantities now represent gallons. They both represent gallons, just like the 9. So if we start with that and we add 9 to it, that's going to equal this many gallons here. And we now have an equation. there's at least one other way you can do this problem that looks pretty different than this, but and that would be fine if you think of that. But this is how I'm doing it, and it is a good way, of course. All right, so I'm going to let's see, where's a good color to use? Okay, so I'm going to subtract 1/5 x from both sides so that I can get the two x terms together. So I've got 9 equals 7/10 x minus 1/5 x. Okay. So the least common denominator will be 10. And when I multiply the second one by 2, by 2 over 2, I'm going to get 7/10 x minus 2/10 x. Now I can combine them, and 7/10 minus 2/10 is 5/10. But 5/10 can simplify down to 1/2. So it turns out that getting that this interval right here that we traversed was exactly half a tank. Oh, okay. So if we multiply both sides by 2 to cancel those 2's, we find that x is exactly 18 gallons. And so, well, that matches up exactly, which I wasn't expecting, exactly with my estimate. So I feel very comfortable about that answer. Plus, I looked at the answer book. Okay, last week, Joe's restaurant counted its lunch and dinner customers. The double bar graph below shows the results. So it's called a double bar graph because each value along the x-axis has 2 bars associated with it. Okay. And it says that bar, which I think is red, but I don't really know for sure, and my family's all downstairs playing a game, so I don't want to bother them. Say, hey, what color is this? Okay, so the solid one is lunch, the striped one is dinner. How about that? I think we can all agree on that. So the double bar graph shows the results. Use this graph to answer the following question. Ooh, okay, estimate the number of lunch customers last Tuesday. All right, if I have to. So we're talking about Tuesday, right there. And we're talking about lunch customers. So that's the solid bar over Tuesday. So estimate, that looks like it's going to be, I don't know, about 90. Okay, I'd estimate about 90. Based on the information given, we are not likely to, well, we're not going to get the exact answer, or at least we're not going to get the exact answer and know for sure that we have it. Anyway, yeah, that's what we got going on there. What else have we got? Let's see. Which days had more dinner customers than lunch customers? Okay. Which days had more dinner than lunch? So dinner is striped, lunch is solid. And so when is striped bigger than solid? Well, on Friday it is, and on Monday. So Monday and Friday, that would be our answer to the second part, right? And the third part says, on which day were the fewest customers total? Oh, okay. So on which day is the solid and the striped bar combined going to be the smallest amount? Okay, I think we can all agree that that's going to be Thursday. I mean, Thursday. Who wants to go out to eat Thursday? Well, if you don't want to wait in line, apparently that's a good day for it, according to this graph. Yeah, so it has, so if you combined its solid with its striped, that's going to be smaller than combining those two, or those two, or those two, or those two. Okay, so our answer would be Thursday. And you want to see something really cool? Watch this. It's almost like a magic trick. I'm going to hit solve and Shazam. There it is. Now, right along with, oh, another neighbor just got home. Right along with graphing is learning how to use a coordinate graph with this x-axis here. That's why it's got an X right there. And this axis here called the y-axis. Um, okay. Um, so you have these two main lines here. So I'm going to write it out. It'll be easier to read. So the horizontal axis we call X, and the vertical axis we call Y. How do you remember? I did have a student years ago. He gave me a very vulgar way of remembering, and which I'm not going to give. The way I remember is it's alphabetical. Just as X comes before Y, horizontal comes before vertical alphabetically. So the two that come first alphabetically are there, and the ones that come second alphabetically, they go together. So when they say give the location of Madrid as an ordered pair, where's Madrid? Oh, right there. Okay. So you always start right there at the origin. The origin is the center where the x and y axis meet and has coordinates 0, 0. Because to get to the origin, you haven't gone anywhere because that's the starting point. Okay. And it says right here that the first coordinate is always going to be your x. So how far do I go in the x direction, the left and right, the side to side direction? And the second coordinate in your pair is going to be the y, or the up and down direction. Okay, and notice these two are written alphabetically, first x, then y. So to get to Madrid, we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to go 8 to the left. Now notice to the left, you see it says -6, -8, -10. The left is negative, to the right is positive. Okay, so it's a very positive thing to choose the right. Okay, in your life. So our x coordinate is going to be -8. All right. And then what do we have to do for the y? Well, we got to go down. Well, up is positive for y, and down is negative. So we're going to have a negative something. So we're going to go down 1, 2, 3, 4, 5, 6, 7. We're going down 7. So the address or coordinates of Madrid is -8, -7. And that gives us an exact location. So making sure you know how to read this stuff can be very useful. If we want to go to Bern, Switzerland, then it would be, we'd go over 3 and then down, 3, down 3. Notice my side to side, my x direction came first, and my up and down, y direction came second. That's how we do it. All right, last thing here. Use the pencil to plot -4, 5. All right, so the first number, that's our x. So we go in the x direction, -1, 2, 3, 4. It says negative, so I'm going left. If it said positive, I would have gone right. Okay, then it says in the y direction, go +5. 1, 2, 3, 4, 5. Okay. So that's the -4, and that is the -5, and therefore my answer is going to be right there. Okay, and that is how we do it. It's not super hard, but you do need to know how to do that because of what's coming down the road, and it's just a good idea just to know how to read a graph. Okay, because you see graphs in jobs and magazines and things, and prospectus for investments, and graphs are something you actually use. Factoring polynomials, not so much, but graphs, absolutely. Okay, that'll do it for today, I believe.